everyone. Welcome to today's webinar on everything you need to know to invest in a leafy greens production greenhouse. Thank you so much for joining us today. I'm Janine Wright. I'm the Senior Communications Specialist at Prospient, and I'll be your moderator for today's webinar. Before we get started, I want to mention that if you have questions during the presentation, please feel free to enter those into the chat box or the question box at any time. If they relate to what we're talking about, we'll try and get to them right away, and we'll also leave some time at the end of the presentation to answer more questions. So our presenters today are Burke Metzger, General Manager of the Produce Division at Prospient. Burke has more than 25 years of practical experience in both the U.S. and European greenhouse industries. He's our go-to expert here for all things related to growing projects to technologies for the produce businesses. We also have Tony Barendreck. He's the technical sales manager in Prospient's produce division. He works closely with our customers on greenhouse growing projects, and he's worked in both the Dutch and the North American controlled environment ag industries for more than 30 years. So with that, I will turn the time over to Burke and Tony.
Wonderful, thank you. Welcome to everyone that's joining us here. We can jump one slide ahead in the presentation. We'll play this as a ping pong between Tony and myself. We'll be going back and forth, very relaxed here. So briefly, the overview, just a few bullet points. We'll talk about how to choose the perfect is an aspiration, the perfect growing system and greenhouse. We'll be talking about germination, propagation, and finally different growing systems, what types they are, some characteristics of them when it comes to capital expenditure and operating costs, yield potential of the system and the risk levels, and then we'll talk about greenhouses themselves a little bit. So if we, so I'll start with this one, and then Tony, I'll hand it over to you.
Absolutely.
So we wanted to start the thinking process a little differently, and what we call thinking right to left and not left to right, because it's always strikes me how many in how many instances a very, very important thing is very last to be considered. That is, who will you sell to? What volume can you place in the market, and what price do you think you're going to get for the leafy greens in this case? What are you going to be growing? How will you get it to market? We've seen several examples where we have great business plans, we have great aspirations to expand to a lot of acreage, and if you really dig down in the business models, what's your go-to-market strategy? Do the logistics work out if you have a lot of acreage of leafy greens in one location? How do you have the ability to combo it with something that this is not given enough attention, and the surprise comes when you're finally ready to produce, and you then have your premium customers maybe, but you have a lot of other volume that has to go with it, and then your business plan is kind of out the door fairly quickly. So that is a prime consideration that, in our opinion, has to be number one. What market, what volume, against what price. And then from that consideration, work backwards to the end goal, to the detail of your business plan. Tony.
Yeah, so quite often I get these questions. Oh, I want to build a 10 or a 15 acre greenhouse for lettuce production or leafy greens or strawberries, whatever it is. And quite often, when I say, you realize that your facility will produce 25,000 heads of lettuce per day. Have you given it some thought where that product needs to go? Sometimes you get requests like, yeah, I've been to several grocery stores and there's not a good strawberry on the shelf. If you look at the expiration dates, they've all been harvested like a week ago. There's got to be a need for fresh strawberries grown right around the corner from me. Yeah, I don't want to play devil's advocate, but yeah, I feel that I need to point them in the right direction to investigate at least what the reasons are behind it. It could be that it's produced at a much, much lower cost compared to in an environmentally controlled space. And then, yeah, the business plan is going to fail eventually. People quite often start midway someplace.
Mm-hmm. Another consideration that should be at the very front of your plan is: do you expect future expansion in the location? Did I think about all when it comes to, for example, the germination propagation part of thing? Do I have it located so I can scale this up? How many more phases can I fit on the property? My property access, but do I bring my utilities to? Is it in a good spot? Is it in a bad spot? Get the big picture right out of the gate, because again, we're seeing quite often there's a beautiful facility with 6 acres and a germination propagation facility jammed in a corner. Then the expansion comes. How do we get the young plants into the new greenhouse, for example? So that's another important consideration. Can you jump back one more quick time, please? And then other important considerations is obviously the building location, what is the local climate? We'll talk about that a little bit more. Again, labor is another one of these things where we less in the leafy greens because it's less labor intensive, but is it available to you at the quantity that you need in your respective location? And don't overestimate the availability of local labor. Have you considered program H2A labor? And then utilities, are they there sufficiently for the current build out? Will there be enough for your future expansion? Now we're ready to move. Tony?
Yeah, so this slide, how to choose the perfect growing system in greenhouse. I don't think there's a one size fits all. It all depends on at what cost price do you need to produce. So it might be also from a perspective of risk mitigation. That you will choose a more conservative growing system, a more, call it, safe growing system. If you lose your power for a day or the main water line breaks, that at least you still don't run a risk of total failure of your crop at large expense. So all these factors come together in one place, but each of them need to be evaluated in the business plan phase to protect your investment. And then also we got to look at consumer concerns. Although I find U.S. customers are not extremely educated about what is good fresh produce, most likely because they don't get a chance to see it very often, or if they see it at like a Whole Foods, for example, for double the price, they walk away right away because it's so expensive. But food safety is definitely becoming a more important factor. People look at, is it fresh? The strawberries from Florida or from California in a New York store, it's doubtful that is called fresh. And food miles and low carbon footprint are also some things that consumers get more concerned about.
Mm-hmm. I'm going to jump back to 3. I think we get into that a little later again. But is the solution the best for your crop? Or do you know you're going to stick with that in lettuce, with that particular crop? If you decided to go for head lettuce, right? Is cut leaf a potential? in an expansion only, or do you think you might have to convert some of your acreage to cut leaf? So once you decide for certain systems, you're going to be tied to producing a certain kind of lettuce. So you really ask yourself that question: how much flexibility do I need, or am I set, and can I just make that decision and be specialized on a certain type? So it doesn't come and surprise you later on if you find out I can't really just switch.
Yeah, the investment might be really high to, if the market demand shifts to different crops, and your growing system is not adaptable to it, or it requires a second type of harvesting system, or it requires different propagation germination methods. Those are all factors to think of when you're in your planning phase. So I guess next we start talking about growing systems for leafy greens. What are your options? And then next we're going to look deeper at each system with pros and cons, levels of automation. Do you keep it manual? Do you want to have it partially automated or highly automated? And what kind of risk factors come with it? So a traditional method is, of course, growing in soil, although you got to have good soil for it, and the soil cannot heat up too much. So in a hot and humid climate, or in a desert climate, or even in like the Midwest, it is probably not such a good method of growing. But it is natural, and you can do it organic if you want. We'll look at it some more a little later. The next one is nutrient film technique. So for those that are not quite familiar with the different techniques, you continuously have a thin film of water past the roots of the crop, and the roots will take up that water and the fertilizer in it, and grow that way. All excess water is collected and reused. New fresh fertilizer added to it and reused. Another method, a little bit similar, is ebb and flood. Basically, you use trays that the crop is in. Is quite often used in microgreens. So frequently, a half an inch, 3/4 of an inch of water is pumped onto the table or the insert that the crop is in, and released, and that allows the crop to take up fertilizer and water. And then the last one in the group is deep water culture, where people grow on rafts, whether those are styrofoam rafts or polyethylene rafts or polyethylene gutters. But the roots of the plant continuously sit in a pond of water. And then next we'll look at low automation levels and high automation levels. The next slide, please.
All right, this one is in between. We'll get back to the growing systems, because at the front of all these growing systems, somebody has to germinate a seed and then propagate the plant to a certain size before it then ends up in the main system, or it might end up in the main system right away. So there's different ways of doing this step. So you can have a separate from your the rest of the greenhouse installation, a growth chamber where you do your germination, and then you come out of it and go into your system. Some of the moving gutter systems, the germination propagation section is actually underneath the actual system, and the gutter then comes, once it's germinated, it comes up and then enters the the moving gutter system. You can do it straight with your ebb and flood tables into the tray. And that's, I think, Tony's and mine's favorite. It's a good solution. It's capital intensive, but the output per greenhouse acreage is going to be the highest with them, is to have what we call a hybrid. You basically have a vertical farm up front of the whole process, where you grow in layers, you germinate in there. You will, there is systems out there applied that are patented somewhat by certain companies, where you even have 2 separation steps in the vertical, and then you're growing out in the greenhouse for a very short amount of time. So your output per greenhouse acreage square foot is very, very high. There is an automation process involved in this as well. So in the vertical farm, especially, what we like with the vertical step up front is you'll have a fast start of the seed. It's going to be very uniform and complete. It's completely controlled. So the more uniform you start out the crop, the more uniform product you will end up having. It can be fully automated. And that's as I just referred to it, you will have a very even production and uniform crops. Another trend we see that upfront vertical situation. If we see a trend this in the normal young plant propagation, this is starting to grab hold as well, because again, it's an industry where the more uniform of a young plant for any vine crop you can start with, the better your success is through the year. Everybody wants every plant the same and perfect, and that there is something to be said for that. And I think there's some big ones going in right now with quite a bit of acreage, and hopefully that concept will prove itself out.
Yeah, so Burke, in addition, in the vertical farm, if you have a plug that fails, it took up 2 square inches. And once you go, if you have a plant that fails when it's in the greenhouse, whether it's leafy greens or lettuce, but it takes up more space there because your density is set for a mature crop.
Yep. So. And it's probably also an area where a lot of attention should be given to propagation and germination, and I think the focus is shifting more towards it. But it was in some of the earlier projects, I think it didn't get the attention it deserved, and there was issues with this.
Yeah, so definitely, I remember visiting a customer in California, in this case, deep water culture, and counting the amount of trays that had it out of 12 plants that were growing in it. At least, 2% of the space had a failed plant that it didn't come up. So right off the bat, this grower lost 2% production, and that's a lot of money at the end of the day.
Yeah. So we're getting into some visuals. I think this is the traditional growing in soil method. There's a steaming process involved, and it's kind of the closest you can get to field production in a greenhouse.
Yeah, and look in the picture also about the uniformity of the crop. Some rows have a fairly full plant, but then you see also some spaces with just tiny plants still. So in growing in soil, having uniform crop and harvesting all at once is tougher. You may have to skip some plants while harvesting and come back at a later stage. Next slide, please. Yes, so it is possible to automate your harvest. Here in this case, it's a machine for in the field, but they also exist for greenhouses.
Yeah, you'll definitely have batch output that way, right? You don't have a continuous production system because you can't just plant.
Correct. Yeah.
5 plants every day, or 2 rows in a soil culture.
Yeah. So here's an example of a manual NFT system. So here you see from the center aisle gullies, gutters that are sloped down towards the sides of the greenhouse, and you can see the irrigation brought in on the front side, and the water will run down to the far end, and whatever water isn't taken up by the plants runs off. You can see for harvesting, they will grab a 10-foot gutter or 12-foot gutter, and bring it to turn it to the center and harvest right there. Or sometimes they'll bring it to the end of the greenhouse and harvest and pack there. Works well for a small startup that might be wanting to supply to local restaurants or farmers markets. But it's definitely not set up to be able to expand so easy. Next slide.
So this is the automated NFT gutter systems. I think that's probably commanding the majority of the new market right now. These kind of systems, those are your green automations, it's your green production systems, it's your hoarded plant systems, different ways of transporting different gutters the same way through a greenhouse. You normally have a 12 or 12.5 meter bay width. That's the length of your gutter. You have a seeding side or a young side of the crop, and you have a harvesting side, and it travels the length of your greenhouse bay from, depending on your propagation system, from after propagation, maybe immediately afterwards it comes out of germination, all the way to a fully grown crop. It's on the other side. The gutter comes out. You will harvest it. The gutter gets cleaned. It gets returned. It gets seeded again, and it goes to the front, and the process starts over. So if you look down those bays, you can see small plants in the front, and slowly, gradually to a fully grown plant in the back. That's probably, as I said, we see that the most going in various manufacturers when it comes to the actual greenhouse acreage, and then depending on what system goes up in front. Highly automated, barely any people in the greenhouse, food safe. A lot of the systems, well, most of the systems proven. The devil's in the detail again. You know, what kind of plug do we use? What am I actually growing? What's the right spacing? There's very narrow gutters. There's a little bit wider gutters, and what we see in this bill in this picture now. So it comes in all flavors.
Yeah, and as the gutters go down towards the harvesting, at some point they will get spaced further out, so the crop density adjusts itself during the travel to the harvesting side of the greenhouse. So in case of leafy greens, this is with regular lettuce, but in case of leafy greens, you see right directly into the gully. So your density from in one direction is set already. You can't change that anymore. But in the other direction towards the harvesting, you can space the gullies further apart, and
it will open up. Which can, if you look at climate, it's a challenge that we're facing every once in a while, because in the early phases, as what you see in the picture here, when they're tight together, if you have any climate going on underneath your gutter, you have slurves in there, for example, distribution tubes. You need to take into consideration that you're fully closed in the front and that you have bigger gaps in the back, and it's going to impact your climate and how the air gets distributed.
Yeah, so in the list of suppliers, you didn't mention FGM. They were the ones to supply this picture.
Yeah, I wasn't trying to be complete. Until I forgot a couple or three.
That's okay, but you advertised for other three suppliers, so I figure we add this one in.
Yeah, absolutely.
So here's an example of ebb and flood. In this case, it's actually an indoor facility. It's larger trays that can move with a roller system, very similar to what you see with rolling containers from the various suppliers. And if you want, you can start to stack them vertically. And you can bring the trays out to the area where you want to harvest. In smaller facilities, you'll see that they usually take a 4 by 2 foot tray that are put in racks and then manually pulled out and harvested and then manually washed and put back. In this case, when a tray is completely harvested, it goes to a washing line where and the dirt gets dumped out, or any waste gets dumped out. The tray thoroughly washed and disinfected, dried, and prepared to be replanted, and it goes right back to its location in the warehouse or in the vertical farm where it belongs. We can do the next slide. Yeah. So here it shows a little bit of the automation. If you do it with rolling containers, that can all be controlled from a control room, where they travel to, what the climate is the best for them. Yeah, all these factors count. We do not see it typically for leafy greens, but quite often for microgreens, for example.
And then the last system that we had was the deep water culture, or ponds. Basically, you have a buoyant raft that supports the crop, and it more or less floats on a water-filled basin / trough. And it's number one, it provides a constant water supply. The roots are constantly in it, and it also is a way to transport it through the greenhouse, because it just slowly floated down the channel from one side, again, where it's young, all the way down to where you will be harvesting it. On this one, again, also the spacing is set throughout, because whatever you have in the tray, that's what you get, and they're normally tight together when they're on the ponds. And we can jump one slide forward. You can float these things all the way to your automatic harvester when they come out, or basically lift them out of the water, throw them on a conveyor belt. They can go to the harvester. They can be harvested right there at the end of the bay.
Yeah, so you can have different density trays. So you can start with narrow spacing in the propagation phase, and you can transplant them to a larger tray, or a tray where the holes are spaced further, but you have less density to play with compared to a movable gutter system.
All right, so that was an overview roughly of what's out there. We will try to give you a high-level overview of some of the economics on the different systems. So we will compare very high level the different levels of, and there's always, this is a guide, because a lot of it depends on how many bells and whistles you put on your system. Again, also how many bells and whistles you have to put on your greenhouse. We get into that a little bit later. How are you cooling, and so on and so forth. So obviously, the soil grown system, it has the lowest capital cost. We rated the NFT gutters are probably your highest, followed right by the ebb and flood system, and then deep water culture. There's less mechanics in the greenhouse. There's less moving parts and motors and pushers and everything else in there. So that's why that got rated with a 2x. When it comes to the OPEX, Tony, I'll let you speak to that.
Yeah, so when it comes to soil, you will do some tilling during the season, and perhaps once a year, you will steam the soil to eliminate any diseases. At the end of the day, it's still relatively low operating cost. If you go to movable gutter systems, yeah, you have your standard cycle where once you've harvested, you will dump out the trays, you wash them, you disinfect them, you plant them up, and you reuse them. However, a bunch of it is mechanics and sensors and electronics. So you have to take into account that you will be spending some maintenance cost on that during the year to keep it up to par. And I think if you go with rolling tables or rolling trays like ebb and flood, there are even more movable components, rollers, air cylinders that push up the benches. Benches get turned 90 degrees. There's more work and more maintenance to be expected in the future. When it comes to deep water culture, you have this 9 inches or 12 inches of water in a pond. Pumps keep moving it, but every so often your pump will need to be replaced because it's at the end of its life. At the same time, you got to think of a liner can go bad after 6, 7, 8 years, and you would have to empty your pond completely. That will be a good thing to do for maintenance as well. I don't think you can continue to grow infinitely in a deep water culture. The water has to become stale over time, and you will have to replace it. So that's a high level view of that.
Mm-hmm. Let's get into yield potential and risks at a very high level. So not surprisingly, if you go from soil from a yield potential is ranked on the bottom, and the higher intensity systems, again, is the gutter system is probably the one on the top, followed by the ebb and flood, and then not far behind would be the deep water culture. Looking at risk, and that is risk when it comes more to redundancy. If something happens, obviously in NFT, you're exposed. If something goes wrong with your system, you don't have a redundancy there. Those roots need to be in the film. The risk that if something happens that it will impact your crop is high. Similarly, with the ebb and flood, both soil and the deep water culture, you have a bit more redundancy when it comes to that. That's why we rated it like this. Obviously, any risk level depends on your crop management as well, and the greenhouse that you have around your crop and your disease management.
Yeah, and so about the yield potential also, Berg. In growing in soil, there are not too many parameters that you can play with. Maybe you change the fertilizer solution a little bit to boost production. Products like NFT gutters or ebb and flood tables, the grower will have more steerability and more tools to maybe in the future increase production. I think also maybe, and you might be able to speak to that as a former grower, like growing in soil has been done forever. So there's all these varieties that are currently already available. One that grows better in April, one does better in September. But for in greenhouses, I don't think that there's such a large range of varieties to pick from.
I think that it's very proprietary what works and what doesn't work for certain growers.
Okay.
I don't. That's what we see out there when we go to this different projects. It's definitely information. If it works for someone, that's relatively guarded and held close to the chest at times.
Yeah, and at the same time, I when I read the magazines, you see that seed companies are still investing in doing more research to develop more and better varieties for those kind of growing systems.
Yeah.
Okay. All right.
Burke and Tony, we have a question. It says, I think you described risk level as surviving mechanical failure or power interruption, but what about food safety? What system has the lowest food safety risk?
We will get into this a little bit. Excuse me. Hang on 1 second. There we go. I'm sorry. From I think every single system, regardless what's in your greenhouse, the biggest exposure on the food safety side, I shouldn't say the biggest. One big exposure is if you have breakage of your covering system, as far as in glass breakage. That is a food safety concern, and with the moving gutter systems, it's always a big problem because you will have to clean a relatively large area, and it's just depending on what area you lose the glass in. This is one thing. When it comes to soil and deep water culture, I'm from a water health and sanitation problem and the potential of having a food safety threat out of the growing medium itself. I would probably rate that a little higher than the others. If you have NFT and you have your active carbon filtration and everything else in there, I would probably put the gutter system at the top of the line. As long as your cleaning is good, in the cleaning step is good. And again, you can see very messy gutter systems where it's an open gutter and it's a loose growing medium that's used. And you can see very, very clean gutter systems where you have a plug and where you have no growing medium all across the system. So, but the biggest threat that we normally see is what cover medium do we have up there, which is mostly glass, and what happens if something breaks. And does that get caught quick enough, and how big of an area do we have to, and how easy is it to get to, because you have to crawl under and get these gutters out, make sure you catch all the glass. So you'll be not selling a big chunk of your production when that happens.
So if the question relates to risks like E. coli or similar, I think we can say for CEA production that is not an issue. 99% of the growers will sterilize the water and sterilize the equipment that they're working with, and the product might be handled during packing by humans, but in leafy greens case, that is just about not the case either, unless they need to weigh off the clamshell with the product before it goes to the store, right? Those are the only possibilities on paper.
Mm-hmm.
But has it ever happened? I don't remember any recalls from producers for those aspects.
We had one instance in Kentucky not too long ago. That did happen in the system.
Okay.
It can happen.
It can happen.
Yeah.
But here at the risk level, I think we mostly looked at the redundancy factor of it, right?
Yes, we were going by growing system.
Your main water main breaks, and now what? Or the power went out, and how long do you have before it starts to negatively impact your crop?
Yeah. or it's a design decision. Do I need full load, full continuous power backup in the location, which might be advisable.
Right.
So here's some of the greenhouse considerations. Obviously, you, depending on where you're located, make sure you know your local climate inside out. I think it's becoming a common practice that people do that research and do the investigation. What's happening, obviously temperature profiles, light levels, humidity profiles, and then design the greenhouse or the growing system accordingly. And which normally what happens, you'll probably engage some consultant that will give you the parameters that are ideal for your crop. You see what you have going on the outside, you layer your greenhouse systems on top, and then you have to make the decision, do I want to have ideal conditions all the time and spend X? Do I want to have ideal conditions most of the times and spend Y? Or can I live with the ups and downs and just go with the flow and spend Z? So that's a decision-making tree here. Beyond that, the type of covering, we just talked about glass and what happens if glass breaks on top of these systems. There's alternatives out there. You have, Tony, help me. There's a brand name there that's called F-Clean. There's a short...
yeah, that would be ETFE film.
Yes.
So I think we can go to a slide that shows it.
Yeah. Well, do we have a slide that shows it? Let's stick with that list for a minute, and it probably comes up later.
Yeah. So
the type of covering, the type of venting that you have in your greenhouse itself, and then the growing system itself in combination with heating and cooling, and that's where I see quite often heating, if it's needed, it's standard. There's not a big discussion how it's done. It comes to once we come to cooling. And we get into mechanical chillers, and is it a patent fan? Is it a combination of patent fan and mechanical chillers? How much cooling load do I actually need? How expensive is it? That's a hard decision-making process, because it can become very, very expensive depending on the location and if evaporative cooling works for you there or not. That if you have to supplement with mechanical chilling, then it becomes very capital intensive. Yeah, we talked about the capex and the opex. It plays into these projects. You can spend, when it comes to lettuce, if you spend on vine crops somewhere between $1.2 to $1.8 million. Once you start looking at a lettuce situation, you can spend anywhere from $3 to $10 million an acre. It all depends how the system comes together and how complex it is.
Yeah, and then that goes back basically to the second slide where we talked about what is your goal, what do you want to achieve in your business plan, right?
Yep.
So. Okay.
And then expandability was the last bullet there. Is my how scalable is all this? It comes to tank sizing right off the bat. Your cold water, hot water storage tank. Do we go for initially right away for a tank that will allow the full build out? My warehouse size. How can I scale the warehouse in phases? And how do I locate the project so I can scale my corridors, and I can scale the production area, and I can scale my germination propagation? How do I lay it out on the property that's available to me? Is there an opportunity to buy more next door? Those kind of considerations. Tony, do you have anything else?
No, I think you've covered it well so far, and I guess we can get into it a little bit more once we get to the next slides.
Mm-hmm.
So for the next slide, looking at greenhouse considerations, we basically defined like 4 different climate types. We looked at how much light you have from Mother Nature, how much your heating needs will be, and how much your cooling needs will be. So we started off with a hot and humid climate. So let's say southern half of Florida, or maybe 2/3 of Florida, or Mississippi, Alabama, southern Texas, because of your cloud layers. At the end of the day, there is a little bit less light available. You may not need a little bit of heat, but most likely you can do completely without. Maybe on the odd cold winter day that it would be nice to have some heat. But the biggest factor is your cooling needs. And yeah, like you described before, you can spend tons of money on mechanical cooling, or do you go with a lower cost option like pad and fan cooling, for example? Yes, pad and fan cooling will do part of the job, but you will also sacrifice some of your production, as we've learned from customers. If you talk about a desert climate like Arizona, New Mexico, parts of California, yeah, you have plenty of light, or part of Texas as well. But the nights can get colder, so you will need heat to keep your crop comfortable. But at the same time, because of those extreme hot days, you're going to have quite a bit of cooling needs. In a desert climate, you will be able to do it with a lower cost pad and fan cooling system. But perhaps you need additional cooling or partial cooling for part of the day. If you take the Midwest area, yeah, it can get cold in the winter, hot in the summer. So it's like a moderate need for heating and cooling. Also, you have a little bit less light available. And if you go to northern climates like Ontario, Quebec, Pennsylvania, New York, all the states in the Northeast, yeah, you have less light available overall from the sun. You need a fair amount of heat, but also a little bit of cooling needs. And if you translate that into capex and opex, yeah, for hot and humid climates, you will still have to invest in a fair amount of equipment and maybe extra curtain systems in the greenhouse to have a comfortable environment for the crop. And because of all that equipment, you have a fair amount of electricity costs. You do have the ability of saying, okay, I'm not going to put in chillers that cost me $50,000 in electricity every month. I'll do it with pad and fan, but I sacrifice maybe 10, 15, 20% of my production. Your market might be fine with that. Yeah, similar story applies to the desert climates. In the Midwest as well, you spend a fair amount of heating costs, and you got to install all of that equipment. And also, yeah, in a northern climate, you will have a fair amount of capacity of heating to install to keep the crop at 65, 70 degrees. That will cost you a fair amount of cost in the winter. And yeah, as far as capex and opex, yeah, you can maybe keep the greenhouse at 60, but the production cycle will slow down and you have less production. So those are some of the greenhouse considerations.
Basically, the cooling needs is a big OPEX driver. We see maybe that X on the northern is a little light, the 1X in OPEX, because you're going to be spending a bit of money on lights.
Yes.
To light the crop, but the light intensity is not all that crazy when it comes to leafy greens.
That is true. So yeah, here's the list of the 4 different greenhouse coverings. You want to take it from here, Burke?
Sure, I can take that one. So obviously, a traditional glass, normally tempered. It could be with a coating on it, whether it's diffusion haze or whether it's got an anti-reflective coating on it. The light transmission, obviously, is good. Insulation factor is very low and food safe. It's got 1x. It is not if something were to happen. So the ETFE is the one where I do believe as we climate change proof some of the designs and we have more severe weather events, I think we'll see more of that. It's comparable in cost to glass. The light transmission is comparable as well, and it also stays comparable. Insulation factor, if it's single layer, is very limited, but it is very food safe because it's very resistant to tear, so nothing will fall on your crop. Also easy to fix if it should tear, but it's very it has a very high integrity and is almost impossible to tear it. On the polycarbonate light transmission is obviously less insulation factor. If you go to double, triple, 3, 4, 5 chamber polycarbonate, if you get some insulation out of it. It is also very food safe. It could be that it blows out and you have to it could be a little bit of an impact. It could almost be a 3 on the food safety too. And then you got the double poly film on the light transmission, especially if you get into year 2 and 3, you'll be sacrificing light. Insulation is good if you keep it inflated, and food safe is food safer than glass. However, you'll have a period when you replace it where your greenhouse will be open for a short period of time, and then it will be closed again when you put your film back on. On the bottom, we're comparing the costs. So glass and ETFE, the investment comes out to be roughly the same with the by the time it's installed. Cost over time should be very limited, and maintenance should be very limited as well. On the polycarbonate, it's probably the highest initial investment, with a little bit higher maintenance cost and cost over time, because you will probably have some yellowing and you will have some stuff that you have to replace. And then a double poly film, well, no, it's probably the lowest initial investment, but you'll be changing this stuff every 3 years, maybe every 4 years if you're lucky. So it's an ongoing thing that you'll be doing as long as you're in this greenhouse. So those are the comparison. I need to say, I would say from the projects that we are doing, I would say basically 100% is glass covered with varying degrees of haze. That's what we see out in the marketplace on the larger scale projects.
Yeah, so over time, ETFE will come in more, right? Especially for crops like lettuce or leafy greens.
Yeah,
just for the food safety concern. Yeah, so those that are new to it, it's a Teflon-based film developed in Japan in the late 80s. It's been in use in Japan since then, and it is slowly now spreading around the world, but it's at a slow pace. Builders have to get used to it to install it. It's not like throwing some glass on the roof. But yeah, it is a very promising product. So we can go to the next slide.
Right, this slide is comparing the adaptability or the suitability of the different growing systems to the different climate zones that we had broken down with the geographic breakdown that we have. So on it's suitable for the hot and humid areas. We basically stuck with the NFT gutter systems in the deep water culture, mostly because of the temperature concerns. Tony, help me out. The ebb and flood one, why did we give it a no?
I think the water temperature concerns. There's water on the tray for a short period of time, and right away it picks up radiation and it warms up.
Mm-hmm.
Yeah.
And we in some applications we're cooling the water too, right?
Correct. Yeah.
Yeah.
So like in the if you look in the bottom half of the bottom chart. So if you're in a hot and humid climate and you want to do NFT gutters, yes, that will work, but you probably need both air cooling as well as you need to cool the water that you use for the plants, because the thin film of water in those gullies get exposed to the sun. That water will warm up real quick and it will affect your plants. So when it recycles back to the main building, you will need a chiller to cool that water before you can reuse it. And that also applies, in my mind, in the desert climate as well as in the Midwest. So if you're in those climates, it's almost a given that you have to work with some sort of cooling system with air ducts or slurves. But in addition, you will do some water cooling as well, your irrigation water. And yeah, so in ebb and flood, if you're in the Midwest in the summertime, it will warm up. So with a little bit of cooling of that irrigation water, you will be fine. And in deep water culture, it's almost always a given that you have to cool that water to a certain extent and provide oxygen for a healthy crop.
All right, we're almost at the end. We have one more slide and then we can go see if we have some questions. So these are just some basic considerations to if you scale a site, how you might want to approach it. There's various ways of mirroring it, either vertically or horizontally, or just make sure you can stack the production area and you can stack the front area. It's just something to keep in mind. There's combinations thereof. Depends a bit on the shape of your property as well, but it's definitely something you want to get right with the site plan that indicates what is possible on the site right out of the gate, and not leave put one right in the middle and then decide, oh, now we want to expand, and now we cornered ourselves here. I think that's our last slide that we have. So, Janine.
Great, thanks, guys. We have, just a couple of minutes for questions, so feel free to put those in the chat. Tony and Burke, one question, regarding the expansion and stuff is, with the NFT gutters, say somebody wants to start with a simpler NFT system that's maybe not automated, but they want to move to the mobile gutter system, in the future. What do they need to consider when they're setting up that greenhouse to be able to, scale to that in the future?
I'm gonna give my side of that. I give my answer, and Tony, you can rebuttal me. I think it's a tough switch to make. I would say potentially there's various degrees of automation in the front and the back. If I would want to keep my options open, I probably would go to deep water culture and say, we can have a very manual transportation through this thing and push stuff around and take off manually front and back and then automate that. Once you have a manual gutter system, you won't be automating that. You're going to be taking that out and put an automated system, and there's not a step, add a motor to, and then all of a sudden you have an automated gutter system. Tony, I don't know what you think.
Yeah, no, I fully agree. It is smart to make the right choice up front. So maybe an automated gully system is in your cards, but maybe you need to leave out a bunch of the automation in the head house until you can afford it. So maybe move those gullies manual there until
That's
you
the
can.
automation in the greenhouse, yeah.
Yeah. But yeah, once you start with a fixed gully system, it's too costly to automate it or switch it over to something automated.
Okay, great. All right, we don't have any more questions, so we want to thank everybody for joining us today, and for Burke and Tony for presenting. We've got their contact information here in case you want to reach out to them, ask questions or talk to them about anything they've covered to here. And we hope we'll see you on the next webinar. Thank you, everybody.
Okay, have a good day, everyone.
Thank you very much, everyone. Bye now.